Okay, so we're going to be trisecting an angle, and I am going to be using the second way where you make it have a constraint. So we are given line segment AB, and then we're going to make another line segment going starting at A and then just continuing it out up. Then we're going to use the circle with the center tool, and we can make a circle with a radius, and the radius of the circle doesn't matter as long as you continue using that radius. So we're going to make our second circle using the circle with the center tool, making point D, which is the radius of circle A, and extending that out to the circle A to make it a radius of DA. And then we can make a point on the other intersection with line AC and circle D, call it E. And then we'll use that circle with the center tool again from E to D. And then we will mark point F where that last circle intersects with line AC. The next step we're going to do is create a line segment from point F to B. And I am just going to make these circles a little more hidden because we won't necessarily need to use them right now. And they're gonna be in our way when we are trying to make sure that all the line segments are the same length. So now that we have this triangle looking line segment, or like maybe like a ship, if we put a boat at the bottom of this, or a boat, like a sailboat, and we are going to use the parallel line tool and create parallel lines from starting given the BF. So we click on BF and then we go to point E, and then we click on BF or E, like line E again. I'm just going to use BF because we know that was our base, so it's going to be parallel to that one. And then click on point D, and then we're going to use the point tools, and I have to zoom in so we can see it, and then you click on there, the line of that intersects through point E, and then we mark the point that intersects on line AB, and we call it G with GeoGebra, and then we do that again with the line that intersects with point D, and then where it also intersects on line AB, mark that point, and it'll be called H. So now we have this like crazy looking crisscrossy shape, but what we know is that each of the lines that is perpendicular to line AB is parallel to one another. And each of these triangles consists of the same shape, just not the same area. So they're also constrained to the radius of each of the circles. And because the radius of each of the circles is the same, points AH, HG, and then, or line segments H, HG, and then GB are going to have to be congruent with one another. And if you wanted to check this, we know that if we pull point A, all of the segments are adjusting to this pull because the radius is constraining them, but also our lines that are perpendicular to line AB and that are parallel to line segment BF. As we can see, they're adjusting. And if we pull this in, they get longer, they get shorter if we pull it towards A. So because we added this constraint of the radiuses of the circles and line BF, we know that they're going to stay congruent with one another. So